Hi, my name is Hsiao. I'm an assistant professor in the Department of Chemical and Biomolecular Engineering here at NC State. Our lab looks at soft materials, and you encounter a lot of these soft materials in everyday lives. For example, your skin is a soft material. Your shampoo is considered a soft material because there are particles inside that makes it solid-like. And there are many other types of soft materials that are important, like fabrics, for example. We focus on why soft materials flow the way that they do, and we use traditional chemical engineering principles like fluid mechanics, but we also incorporate a lot of chemistry methods. We synthesize materials with different shapes, sizes, different geometries, and we look at why they flow the way that they do, which is an important industrial problem. And also, it allows us to engineer really unusual properties, especially mechanical properties, into these materials. We use a lot of microscopy methods. We have really beautiful tools to measure flow deformation at the same time, and we can see exactly what's happening on the microscopic level. Some of the applications in our research are related to things like oil slurries. These rocks that are pumped up with simple crude oil actually have different shapes. They can get stuck, which is, as you can imagine, a huge problem. Other issues that could arise in applications are like, what happens if you have two polymer materials that are rubbing against each other, and you might think, when is that going to happen? Well, that could happen in wearable electronics. You might have sweat between these polymer materials. We can tell you what type of surface geometry we could use to really reduce this type of friction. Or if you want, we can enhance the friction, which could be interesting for if you want to enhance grip. We can use the physics to tell you and the chemistry to tell you what would be the right thing to do. So our applications are to look at industrially existing problems, but we also want to develop new materials with really unusual properties. Students in our lab are really working on a lot of relevant polymeric materials. So they use things like high-speed microscopy. We process these images at the same time when we're measuring mechanical properties. This is something that is a little bit difficult to get in other labs because the tools are not quite there. But we have the tools to show students how to do imaging in situ. We look at microscopic engineering, which is something that the field is moving towards. Students will also gain a lot of these problem-solving skills. They will learn how to use these principles of hydrodynamics, principles of solid mechanics to really get this type of material that is maybe not possible in nature, or maybe really mimicking natural system in a way that synthetic engineering has not done before.